Hi guys, you are welcome to my channel. Okay, today we're going to take a look at PLC wiring connection. All right, so this is a typical representation of your connection process. I just use AutoCAD software to bring it up this way. Okay, take a look at it. This is AutoCAD software. So this drawing is a typical connection process of CPU. So let me show you the CPU model I'm referring to. This is for 1200 series SIEMENS S7. Okay, I think I have it here. Okay, look at it here. This is the CPU and the PLC I'm talking about. Let me change the orientation. All right, this is 1200 SIEMENS S7. Okay, so there is one. This portion here is going to be your input terminals where you terminate your input bit. Then down here is where you are going to terminate your output bit. All right. So let's go back to AutoCAD connection. Now here now we are going to take a look at. All right. Now first of all, let's start with the serial number. This particular serial number, this particular CPU, this is the serial number. Okay, like I said, the model is S7-1200 SIEMENS. The product is Siemens. This is their logo. All right. Now, this portion is talking about the output. Now, it's very important you understand your output rating and you also understand your input rating. Now, your inputs are this other one. Your input, according to the specification, the input cell is going to be digital input. This portion is your digital input. Digital input means it's going to be in a category of either is on or off, either on or off, either is 1 or is 0. Okay, so that is the IO we are talking about. Then the voltage rating of the input that you have to terminate is going to be 24 volts DC. Okay, then the current for each of the bit should not exceed 6 milliampere. So each of your bit here is going to resist only 6 milliampere. So the current carrying capacity is not a significant one, so that you bear in mind. So take note, your input current rating is going to be limited to 6 milliampere. All right. So that is the current carrying capacity of your bit. That is what the CPU can accept from your input. All right. Then the output here, the output is said to be 30 volts DC stroke 250 volts AC. So this bit here accept both DC and the AC. Then whichever one that it is, the current carrying capacity of the terminal of the bit shouldn't exceed 2 amps. I repeat, 2 amps. So you should confine your load that you want to feed through this terminal within the current carrying capacity of 2 amps. So in other words, if you want to feed a contactor, if you want to feed a contactor of perhaps 800 amps contactor, you shouldn't come here direct. Okay, if you want to also feed, in fact, if you want to feed a contactor that the rating of the cord, the rating of the contactor is about 400 amps, it shouldn't also come direct. It should interface here with a relay because they have given you the current carrying capacity of the bit, that is 2 amps. So make sure that the load coming to this output should be limited, in fact, should be restricted even less than 2 amps to be on the safer side. The rating is 2 amps, but you should use less than 2 amps, at least 1.5 amps. That is the load that can come here directly only. Otherwise, you interface a relay here before coming to this area. This is the reason why I always emphasize on control system. If you understand relay logic, you know how to interface a relay to the output. But I will show you in my next exercise. Okay, so these are the informations I want to bring to your notice. That is one. I repeat again, the output load carrying capacity of this place demand only 2 amps per each. Okay, then for the input, is restricted to 6 milliampere. That is less than 1 amp. Is less than 1 amp. Is even less than 0.5 amp. Okay, please take note. All right. Now, and take note again, the input is going to be DC. Input is going to be DC. That is the bit, the connection to your input bit. Meanwhile, to power the CPU is going to be AC, live, neutral, and the earth. Live, neutral, and earth. The voltage range is going to be from 120 volts to 240 volts maximum. That is the only single phase voltage that is coming here. Okay. Now, if that is carried, then syncing and sourcing is what I want us to discuss again. But I will do that in the next video. But let me just put a hint here. If you take a look at this connection, I put I can also, let me see if I can copy another one and paste. Okay, don't worry. Let's not interrupt this. I wanted to copy as many switch as possible, but let's just discuss with this. Okay, now take a look at number 4, this terminal 4. Terminal 4 is my live conductor. Okay, sorry, terminal 4 is my, look at 24. This is 24 supply. Yeah, take note, this portion is 220 to 120 to 230 volts only. 120 volts to 240 volts. Then I have another different voltage in this portion. Look at it. They say 24 volts. Look at 24 volts here. So my LU positive is going to be, LU plus is my positive supply for my DC. This LU positive here. Then M here is my negative. M is loop terminal 5 loop to terminal 6, and terminal 6 number is 1M. So I'm looping M to M1 and looping M to 1M. So that is my neutral. That is my, negative. Then LU plus is my positive. So positive is here as common, is serving here as common to feed the whole of my switch. If I have multiple switches here, I loop this common across to all of them. Okay, take note about that. Then when you come to the output side, it is said to use either DC or AC, whichever one that is convenient or compatible to your design. So if you are using AC, then the number 1 here, this is line 1. Number 1 is going to be loop to LU1. The reason for that is because this area here has a separate terminal, and here too has a separate terminal. So when you are working with this compartment, when you are done and you want to enter this compartment, you also loop the supply you have here to here so that you will energize this compartment. Let me show you. Now take a look at here. We have 2 compartments. The first compartment here, both of them are output. They are all DO, digital output. Now, but this first compartment is in charge of a particular set of output. Then here's another different compartment. This one is in charge of another different output. Okay, they put it DCA and DC output A and output B. Okay, both of them are not using the same current. Maybe perhaps that is why it is separated this way. You know, one may be bigger than one. Maybe this one may be direct. This one may be using a relay to interface, some kind of, I know. Okay, now, so that is the reason why you have to loop. When you are done with this compartment, you have to loop from here to feed here so that you continue from this compartment. All right, let me show you back. So that is why there are 2 compartments. So now 2 terminal compartment. Okay, this is line 1. You loop this in line 1 to merge with this compartment. Okay, so in ideal situation, let me see if I can separate. In ideal situation, here is separated, here is separated. Okay, that place is separated, but let me remove it. Okay, so that place is separated. So look at it. They say relay output. That means relay output means that off and on can come here. You don't need any configuration. So relay output is always better so that it can go direct. Okay. So not a transistor output. Transistor output is limited to direct connection. You need to interface other device before it can come direct. Okay. All right. So that is for this output and this my input. Take note. This common here is positive. Okay. This common here is positive. So this positive will feed the whole of your input here. Then while your output, you have a live to loop the two compartments. Then the output coming out from here will now feed your neutral. All right. Okay. For instance, let me see if I say, okay, I want to duplicate. I want to duplicate. Where's my copy? For instance, so if I want to duplicate this, it's okay. I multiply this. I multiply this. I multiply this. They are going to feed across the same neutral. All of them are going to feed the same neutral. Okay, that is the point we are what I'm saying. Then now this area now is going to be our analog input, analog connection. You see, so this analog, this is going to be a potentiometer. Here is going to be our a potentiometer. Analog is not like digital. Digital is either is closed or it's open or it's open. Either is closed or it's open. As either is in a closed mode or it's open mode. But this one is using variance. This one using variance. You know, variance of 0 to a particular threshold. Okay, so now and this analog device can be a converter of converting of different parameters. We also need to interface a DC supply so that we can vary whatever signal that will come in from DC. So this one is going to be our AC feed here. Then DC coming here out will come here. Then this one will get to vary that analog input here before coming into the CPU. Okay, so your connection mainly is going to confine within here and here. We're going to confine here and here. So later we'll discuss about the analog input. Okay, all right. So now, like I have 1, 2, 3, 4 lamp. So I should also have input here to represent them. Okay, so by the time I write program, you understand here more better. We are going to use here to carry out a sketch. Okay, like I've been saying with your control system, I've been putting up a lot of design, giving you drawings, and you know how your input and your output goes. Okay, all right. So the next exercise, I will also put up a drawing. I will make this termination. I will make this other termination. Okay. All right. Thank you.